Why should a magnesium ribbon be cleaned before burning in air? Well, magnesium ribbon should be cleaned before burning in air to remove the thin layer of magnesium oxide that forms on its surface when it reacts with oxygen from the air. This oxide layer prevents the magnesium from burning easily because it acts as a protective barrier, hindering direct contact between magnesium and oxygen. Cleaning the ribbon ensures that the pure magnesium is exposed to the air, allowing it to ignite and burn more efficiently, resulting in a bright white flame and the formation of magnesium oxide as the primary product. Write the balanced equation for the following chemical reactions. First, hydrogen plus chlorine gives hydrogen chloride. The balanced equation is H2 plus Cl2 gives 2HCl. Next, barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. The balanced equation is 3 BaCl2 plus Al2SO4 3 gives 3 BaSO4 plus 2 AlCl3. Finally, sodium plus water gives sodium hydroxide plus hydrogen. The balanced equation is 2 Na plus 2 H2O gives 2 NaOH plus H2. Write a balanced chemical equation with state symbols for the following reactions. First, solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. The balanced equation is BaCl2 aqueous plus Na2SO4 aqueous gives BaSO4 solid plus 2 NaCl aqueous. Barium sulfate is formed as a precipitate while sodium chloride remains in solution. Next, sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution and water. The balanced equation is NaOH aqueous plus HCl aqueous gives NaCl aqueous plus H2O liquid. Sodium chloride remains in solution and water is produced. A solution of a substance X is used for whitewashing. So, let's break it down. The substance X used for whitewashing is calcium oxide, commonly known as quicklime. Its chemical formula is CaO. 2. The reaction of calcium oxide, CaO, with water is as follows. CaO plus H2O gives CaOH2. In this reaction, calcium oxide reacts with water to form calcium hydroxide, also known as slaked lime, which is used for whitewashing. Why does the color of copper sulfate solution change when an iron nail is dipped in it? Well, here's why. The color of copper sulfate solution changes when an iron nail is dipped into it because of a displacement reaction. Iron is more reactive than copper, so it displaces copper from the copper sulfate solution. The reaction can be written as Fe plus QSO4 gives FeSO4 plus Q. In this reaction, iron displaces copper from copper sulfate, forming iron sulfate in solution, which is greenish in color. Copper metal is deposited on the iron nail, and the blue color of the copper sulfate solution fades and changes to the greenish color of iron sulfate. Let's identify the substances that are oxidized and the substances that are reduced in the following reactions. 4Na plus O2 gives 2Na2O. Sodium is oxidized. It loses electrons and goes from elemental sodium to sodium oxide, where it has an oxidation state of +1. Oxygen is reduced. It gains electrons and goes from molecular oxygen to the oxide ion in sodium oxide. 2. CuO plus H2 gives Cu plus H2O. Hydrogen is oxidized. It loses electrons and goes from elemental hydrogen to water, where it has an oxidation state of +1. Copper oxide is reduced. Copper in CuO gains electrons and is reduced to elemental copper.